So, indicators. Indicators is one of the cooler things in chemistry. This is what you typically see when you see a video. Someone on TV shows a chemist. Um, they'll show you solutions and they're bubbling and cool looking flasks and glassware and screwy looking tubes and all this stuff. But there's lots of times there's colors in there. And those colors are due to the indicators, and those indicators tell you something, just like a regular indicator. There's lots of indicators you've probably heard of before. You didn't realize they're indicators. So um, this indicator here, that one, you know what that means. When you see that on your phone or your computer, you know, hey, this thing is thinking. This is the old style of it. The hourglass is sands running through the hourglass, and then would flip, and oh, there's the computer is thinking. It takes a while. You also have the spinning color wheel, but those are animated indicators. There's also indicators that don't move, and something like that. That's a stop sign. The stop sign indicates, hey, up ahead you have a stop at intersection. All right. Another indicator is this one over here. That's an indicator. That indicator tells you we have a traffic control device. That's the fancy term for a stop signal. That tells you, okay, right now it's green, then it goes to yellow, then it goes to red. So those mean different things. They tell you things. Indicators tell you things. If you're following a car, you see a car and it's got lights like that, that tells you, well, either the car is turning, if the turn signal indicators are on, or the brake lights come on, that tells you it's slowing down. Or if all those flash in there, that's telling you it's maybe pulling over or slowing down, or it's stuck on the side of the road. Those are indicators. Another indicator for those of you that start driving is that one. If you see that on your dashboard, that thing's flashing. That tells you, hey, there's something really wrong with the engine. So don't think about, pull over right quick and turn your car off. Call AAA, call your mom, call your dad, call your grandparents, tell you, hey, I have a flashing indicator on my car's dash. There's something really wrong. All right, so that one you don't drive with, but that's a little driver's ed information. So, but anyway, those are indicators in the real world indicators. There's a whole bunch of indicators in chemistry also. Chemistry uses indicators that change colors, and those typical indicators are based upon pH. Table M in your reference table shows you 6 different indicators. If we were in school, we would do a lab that involves 6, would not involve, the litmus, but instead would have a different indicator called the universal indicator, which tells you the pH in different color solutions. So how do these things work? Well, indicators are all pH dependent. So if you have a solution, you can determine the pH of that solution by testing it with one or more different indicators. So, for example, let's take a look at one of these. So this first one here is, let's look at methyl orange. Methyl orange is our first one on our table. Methyl orange is called methyl orange because between 3.2, a pH of 3.2 and a pH of 4.4, it's orange. Well, what does that mean? So if you put this methyl orange in a solution and that solution turns red, well, that means you have a pH that is somewhere down there. It is 3.2 or less. Doesn't it tell you exactly where it is, but it just says there's a pH there that is 3.2 or less. You don't know, could be 1, could be 2, could be 1.4. You don't know for sure, but you just know that the pH is 3.2 or less. If you put that indicator in the solution and the solution turns yellow, well, that means your pH is somewhere above 4.4, 4.4 all the way up to even higher than that. So it could still be an acidic solution way down here, less than 7, or it could be a basic solution way up here, greater than 7. So the yellow just tells you that solution has a pH greater than 4.4. Doesn't tell you whether it's acidic or basic, but just tells you the pH is greater than 4.4. If, however, that solution turns orange, well, if it turns orange, then that means you're right there in the middle. You're right there between 3.2 and 4.4. So you've really narrowed that pH of that solution down. All right. And so if you find a solution and you put this solution and you put an indicator in it and it turns orange, you know that pH is somewhere between 3.2 and 4.4. You can be pretty confident. If you want to narrow it down, you could maybe use another one This one here, bromocreosol green, that's 3.8 to 5.4. That goes yellow to blue. So between that one would be green. So if your solution, you put this, just drop in the solution and it turns orange, you know, okay, it's somewhere between 3.2 and 4.4. But if you put this bromocreosol in that solution, a different clean solution, and it turns yellow, then you know, hey, that solution's pH is lower than 3.8. So you've narrowed that pH of that solution between 3.2 and 3.8. And that's a pretty fine, pretty narrow pH range. And that tells you a lot of information. So depending upon the solution and depending upon the indicator, you can narrow down the pH and determination and figure it out that way. So I have a couple questions for you on the worksheet. So work through the worksheet. If you have any questions, please ask. These are all based upon Table M indicators. Litmus, again, all of these indicators, between them is going to be a mixture of the colors. So a bromothiamyl blue between 6.0 and 7.6, that's going to be a mixture of yellow and blue, which is, right, green. Phenolphthalein, that's how you say that. Phenolphthalein, that one does not have a switch. Between 8.2 and 10.0, that jumps from a colorless solution below 8.2 to a really bright pink solution above 10.0. So that one, there's no indicator color in between those two. Litmus between 5.5 and 8.2 is going to be a mixture of red and blue. It's going to be kind of purple. That one's kind of tough to see. Litmus is really good for either the low end or the high end. In between, things get kind of muddled again. Bromocreosol blue goes yellow to blue, so that's why it's green in between there. Thymol blue goes yellow to blue. Again, that one also is green between 8.0 and 9.6. So all of these indicators have a different transition pH, but that transition pH is indicated here on Table M. All right, so take a look at the worksheet and see how you do on that.